to do whatever projects you want. The main thing is that you don't exceed $100,000, I think, in revenue or so, which I doubt you guys gonna sell things right now at this moment. Probably you're gonna need at least 6 months to 8 months to have some good game that could be sold for that X amount of money. And if you got that money, then or you gain that much money, then you just simply buy the pro version and that's it. So for now, we can use the simple free version, which you have everything except for the dark skin. But this is right now; it's a future thing, not now. So because you guys here are mixed, I think third year is here as well, isn't it? Jel imamo treću godinu tu? Well, imamo, dobro. I imamo drugu godinu, dobro. So we have the second and the third year. Now, there are some prerequisites with C# which I need to bring you all on the same level. So when I start to code in Unity, or like we're going to use the C# normally, but I'm going to use patterns. I'm going to do some other things that probably it's going to be different from what you do in web applications. So there are certain concepts that I need to know, that I need to make sure that everybody knows and everybody's familiar with. So first thing, I will just simply create a new project. And I will call this intro or C# recap or something. Oh, hang on. Create new project. .NET Core, next. Sure, why not? If you, yeah, for admin, if you, you can do 2D. If you want to, you can do 2D if you want to, but I think it will require some artistic side of your. Yeah, I mean, you're gonna need to draw a lot, so you need to make sure that you have the, you have the artistic capability to carry it on. But if you go with 2D, fine. Even though I would say my friendly advice, it will be much easier for you to go 3D because there are a lot of interesting things that you can fake in 3D, and it's going to be faster to do it in 3D. Even sometimes, actually, I've seen projects that has been 2D done in 3D. So just keep that in mind. Anyway, hopefully I didn't confuse you. You will see more what I'm talking about when we get to it, I think. All right, so I'm going to call this recap. I'll hit create. It doesn't matter which version for now. I just need some. I don't care about whether it's .NET, the vanilla .NET or the .NET Core and something like that. Now, first and foremost, before I dive into that, actually, I need a pen, and I need it to be white. So can I actually draw here? Can't I? Okay, I can. For some reason, I cannot draw by hand. Fine. I will go with MS Paint. Can I draw? Good. Now, there are certain things you have to understand about C# when it works. So the first thing is that you need to know that C#, when it gets compiled, your code is being taken. And the first thing which happens to it, so if you write something like console.writeLine hello world and so on and so forth, your code is being taken by the compiler. First thing, it gets lowered. Okay. Then it gets to the then it gets actually to be done. Then it's actually getting converted to a syntax tree. Syntax tree. Sorry for the mouse art here. And then you go, after it goes actually to the syntax tree, compiler optimizations. Compiler optimization. So if you have any stupid code in there, the C# actually will the C# compiler will just simply say, okay, this is repetitive or this is unnecessary, and it will just simply start, based on certain patterns, it will start optimizing your code a little bit. And then it goes through compiling phase, which is going to be an IL. And then the common language runtime, the CLR, will just simply take over and we'll start running your application, okay? Now, this is mainly compiler theory stuff. What I'm cared about here is the lowered part, okay? So when you look at for each loop, for instance, so zoom in, screen visible? Hello? Good. Okay. Everybody still alive? Good. Now, we have, for example, your for each loop, for instance, var item in a new list of ints, and, well, just ended up with 1, 2, 3, 4, 5. I hope that I didn't. Okay, well. Now, if you go and say console.writeLine, item, F5 it, we are going to have the 1, 2, 3, 4, 5. Okay. Now, when this gets lowered, can somebody please tell me how you can rewrite for each? Is there any other alternative for each? You can fake with it. Can we replace for each in some way? For loop, thank you. So we have for loops. So you can write this in a for loop. Okay, I'll just simply put the comment in here. So you can lower this into a for loop. Can somebody tell me how can I rewrite a for loop? While, thank you. So we have while loop. Okay, can somebody tell me how can we rewrite while loop? Aha. No, do while. No. Do while is in fact the same as while loop. So one by one. Actually, sometimes compiler gets an optimization point if it sees a static. In fact, if it sees a static thing, it will just immediately. Just write it down. So if it sees looping from 1 to 10, it will just simply duplicate it, 10 times or so. I've seen it in some compilers. Goto, thank you. So actually, while loop can be written as a goto. If you go into .NET Core source code, you will find somewhere. Hopefully, I will try to dig it down a little bit later, maybe by the break or something. You will see that while loop is written as a goto statement. So whenever you do a for each loop, it goes way down at the end, and it just becomes some sort of either a while loop or a goto statement. And if you are interested, you can go to sharplab.io, and then you could just simply say for each. Well, hang on. So I will not actually retype this again. Let me grab this. Push this into here. So, using system.collections.generic. Yes, so you can see this is your code. This is how the C# compiler does it for you. Okay. Now you have to understand one thing, that this sharplab.io is being monitored by Microsoft guys, internal compiler guys, the guys who are working on the actual compiler. It is known that it doesn't go by the book, but it's quite close to how C# developers or compiler developers have written the actual thing. So this is the closest thing you can get to see a representation of how your code works from the inside. Because this sharplab.io is in fact getting the stuff from the IL backwards to your code. Now, with this method, by the way, people have discovered bugs in other programming languages, and specifically, interestingly enough, in Unity, I think Unity 5 or Unity a little bit later than 5, people had people had the problems with the for each loop because it was allocating and allocating on the memory, and it does actually trigger garbage collector a lot, which drops your frame rate by really heavily. I mean, it impacts your frame rate really heavily. So knowing how things internally work, what things tick, how things tick is super important. So once you run into bugs, you know where to hunt them. So that's an important thing. So I will actually stop right here with the lowering part and how the thing actually flow. Now I'll move on to other concepts. So other concepts because I'm going to use it in the future. First and foremost, you have because some people sometimes drop this or sometimes grab this. You know, sometimes people just miss these low-hanging fruits, I would say. Let's talk about typing. So you have explicit typing, which is, for example, int I equals to 0, and you have implicit typing, where you have int j equals to 0. Then you have var j equals to 0. This is equivalent to this. The compiler can infer the type after the equality sign. You cannot do this because the compiler cannot infer it. We use it a lot. I've seen students make some interesting mistakes regarding it, so I'm just simply saying, do not shoot yourself in the foot and do not do this, okay? The good thing about var is that you can do something like this. So you can avoid something like this of int and float, and then you have another tuple float comma int whatever, and then some equals to new that. So if you would like to avoid some horrendous code like this, you can actually use this, and it will be done for you. The second reason is that you can actually create an anonymous object. So anon equals to new, and then you open the braces, and then you say x equals to something, y equals to something else, and right now you have an object coming out of nowhere, when you can actually, in fact, address these properties, and you cannot modify them, just to be clear, because they are in fact read-only. So if you actually grab this and you would like to see how it looks like, hang on, let me see, where's my Sharp Lab though? Did I close it? Oh, there we go. So if I actually grab this, let me whitelist this guy. Okay, good, now I can see things. Now this is actually getting lowered to creating a sealed class, which doesn't matter. It just doesn't. You cannot inherit from that class or something or many other things, but we'll keep it there. And if you can see here, this is my x, which is here's the x, and it has that something which is going to be set as in the constructor, which you can see right here, and it has only get and get. Hence, it's a read-only. Okay, now I understand why you cannot modify this. Now moving forward. Now, since we understand this fact, you could, in fact, in Unity, start populating a list temporarily with many objects that you would like to shoot out into the scene. For example, you could combine certain properties of enemies on the fly in an anonymous object, and you just simply start pushing them into the scene one by one, and you don't care anymore how they will behave because it's just one-time use of an object and it just will go and you don't need to think about it anymore. Okay? So this is why we use sometimes anonymous objects, and you don't need to create or pollute your code with too much classes. This is one of the ways we sometimes use this. Even though right now with the newest design patterns and everything, it's quite rare that we use this, but it's a good thing to have under your belt in case you needed it. So right now you understand the explicit and implicit typing, and you understand that we use implicit typing in order to do some moves like this, or even create an anonymous object like this. Are we still alive? Good. Questions? Pitanje zamjerke. Ima li nešto još? None? Fine. So I will assume that everybody is alive at their monitor and watching attentively. Okay, now moving on to the scary part, which scares some developers, I think, or mostly scares students, I think. I would like to talk about delegates because I use them a lot in Unity. So, what delegates are? Delegates are types, like classes. You can instantiate an object out of it if you want to. Delegates are what we call in C++ the function pointers. So what can you do with it? Good question. You could do something like this. Delegate, and I make it void because it's a function pointer if you have seen it in C++, and you have to define the signature of the function you are pointing at. So you say void my method or whatever, or my delegate actually to be more exact. So this is the method which doesn't take any parameters, and I just named that type as my delegate. Now, you would do something like static void print something, and then you say console.writeLine something. Actually, there's a new syntax, by the way, for one-liner functions, if you didn't know about, which I think like this. If you have one-line function, you can just simply write it like this and off you go. So if you are making a pull request with something like this, some people will just simply tell you, hey, you could do this. Right now, you know, and I'll keep it that way. Next, if you would like to, you can just simply say my delegate del equals to print something. Sorry, without the braces, because you are assigning the method to the delegate itself. Now what you can do is you simply call this. So either you say .invoke or you say this. Oh, there you go. So either this or that is valid. And you're going to see a lot in code this. If you are doing multi-threading, you have begin invoke. Okay? And as you can see, it returns an iasync result. So it's a synchronous call with an asynchronous callback and stuff. We will not get into that. It's outside of the scope. But right now you know about it in case you run into it when you are doing some ASP stuff, ASP.NET stuff. Okay, so you have those two, both of them are equivalent. So if you write this, it will call this and you are good to go. Okay, and if I hit F5, let's hope it will print something. So something, probably I called it twice. You see, invoke and this is printing. Good. Following so far? Hello? Okay, good. Have you seen this before? Good. Now, let's say why that thing is there. Let's say, for some reason or another, how are you going to use this thing? Let's say you have public bool, list of ints, and you have something like return less than 5. Okay, and you have list of ints, and you pass there the input. And here you're gonna do the regular stuff. You're gonna just simply say var result equals to new list of ints, and then you say result for each var item in input, and then you say result if item item is larger than 5, then you just simply say result.add item. And then at the end of the day, you return the result. This is programming 101. Everybody have seen this probably in C++ when they started just programming. So if you hit F5, nothing will happen because I haven't populated the thing. So var lst equals to new list of ints. Then I'm just gonna do this, the new object initialization syntax. So I just gonna, and then just put have and -1 just for fun. Let's hope I will not break anything. Okay. If you are in the middle of the line, you hit Shift Enter, you add a semicolon, and you go to the end of the beginning line. Okay. That's one trick. Now F5. No, not F5 it. I forgot to call the method. Less than has to be static, because you cannot call a non-static method in a static method. So less than 5, and you pass it in the LST. And if you would like to, Control RR, input, done. F5. Yeah. Bar result for each R item in result. You say you cannot see anything, isn't it, if you don't print it out. F5. Now we have less than 5 stuff. Okay. Now, since we have that, now you do the pull request, whatever you do. You send out your code to your manager, and then your manager just simply say, you cannot do this because if I would like to change the number, I have to work on it again, right? I have to modify the code again. And you go ahead, and then you just simply say, okay, what if I would like to have 15? The guy says, I would like 15. Then you sometimes duplicate this thing, and you do the 15 again, right? And then you add more variable probably here, which is going to be the compared variable or something like that. There's going to be an int. And then you pass it in here, and then you have right now, you do whatever you want. But then things start to get a little bit more dirty, because right now the guy says, okay, I would like to change this to be larger than, or larger than equal, less than or equal. And then you say equals equals, or not equals. And things start to get really, really hairy right now because you have duplicates of this, and your code is not clean anymore. If you haven't noticed by now, your problem lies in this line, because this part you would like to keep changing it all the time, right? So delegates come into play. So you could actually define a delegate, which you're going to call, I'm going to call it a predicate. Now, your delegate is in fact a Boolean, because this operation is a Boolean operation. You would like to know if this thing is true or false. And I'm going to inject the code right into this if statement. So if I say predicate, here's the return statement, and I'm going to, I'm just going to hit the semicolon, I think. Oh, yeah, and it takes an int x. Okay, are we good? Following so far? Good. Now, so we have that predicate. And the interesting here is what I could pass in. I could say predicate, and I say checker, whatever, we can call it like this. And what does the thing accepts? It accepts a number, which is the item, to check against, right? Now, if you would like to call, why the heck did this complain? Consistent accepted predicate is this. Was it because it's or public part? Okay, now there we go. No, I had an error here. No, this is another thing. Right now, this is going to be passed in. Now, here's the interesting part. You could either write this. So public, public. Actually, I could actually, in fact, take this out, and we are good to go. Right now, I don't have any other problems with publics and privates. Bool, and then I will call this the my checker. Don't mind the casing. Okay, let's follow the C# stuff. It's going to take an int x, and then you just simply say x is larger than 5, return, right? You have this option for you, and you can pass in my, hang on, you can pass in my checker, and it has to be static, of course. My checker. And that's it. Right now you injected that thing inside the method, and it will actually calculate it for me. So if I hit F5 now, hopefully nothing will explode. And again, I made a mistake, isn't it? Yeah, it has to be less than 5. So right now it's less than 5, right? Now the other option is that you can just simply get rid of the whole thing and use something which is called lambdas. And you can say x is less than 5. Are we good? Now, this is why Microsoft actually introduced lambdas, just to reduce this pollution of code, so you will not write thousands and thousands of functions that can be used only once. Now, of course, you have a lot of interesting other things that you could get with it, which is other side effects. I wouldn't say side effects, other interesting features like the Y Combinator problem, where you can do recursion with lambdas, which is kind of interesting to see. But this is for you to research. So let me write it for you here. Y Combinator. So you just simply research about it, if you would like to. There is also implementations of this, of Y Combinator in C#. It's a little bit convoluted, but it's fun. It's a fun read. So you have that. Now you have these delegates. Now Microsoft actually have discovered this problem with delegates, and you're going to actually define a lot of these. Now it came later on, it dawned onto them that you could actually introduce something which is called actions and funcs. Now action is a reserved keyword which represents a method, a void method, that takes an X number of parameters. The problem is I cannot write it here right now. I have to write it right there. So if I open it here, it takes up to 16 parameters. Okay? This is a void method that takes certain X number of arguments up to 16. You have func, which it says it takes 0 parameter maybe, and it can return something, or it can take up to also I think 16, was it? Yeah, up to 16 parameters, and you have to define the return result. So I can say it takes an int, returns a bool. Right now I don't need this definition, and we are good to go. Right now I have less code, much smarter, much cleaner, more or less, I think. So if I have F5, we get the same thing. Right now, you know, when you see actions and funcs, you're going to see interesting stuff coming out with it. Now, I use delegates a lot with events because, for example, if I have to handle a mouse click, or I have to handle a keyboard press button, let's say you press the fire button on your keyboard, or a space for a character to jump, or whatever you would like to call it, I'm not gonna write it like if key pressed. I will actually wrap this into another class, shoot it out on the side, and I will put delegates in there with events, and I will wire it up as you can see it here. And I will say, the moment you see some function in there, handle it in the way which I have defined here, and ciao, all of us are happy and dandy and we go dancing, right? So this is how things I'm going to actually model, how I'm going to model these things. Now, this is the reason why I'm showing to you this. I believe that a lot of you have seen this, but because I have seen that the second and the third year are here, I know that probably have seen delegates before. I don't know if you have seen that specific example, how the delegates, where they came from and why and how I'm using it. This is unknown to me. But right now, I think we put everybody on the common ground. Is there is anything that is not clear here? Anyone? Say okay. It's somehow like, is the 84 or 83 people, they're just simply like they they turned on the screen and they went, I think, like they're not alive anymore, right? Well, anyway. Okay, I hope. Well, you see, when you say we are here, like I know, I understand about the passive people who don't just would like to write on the thing, but you guys do not have any feedback whatsoever. I don't look at your faces, so I don't know if you guys are actually following this thing. Have you seen this before? What I'm showing to you right now? Do you know about this stuff? At least this progression. So you have seen it before, right? Okay, is this the second year or third year I'm talking to? This year. Beautiful. Great, great, excellent. Okay, sorry for the boring stuff, but okay, good, good, good. This is why, because I've seen a lot of people in the previous years, not your year, of course, like some time ago. They didn't know about this and it was super confusing. So I actually had to like level the thing up so nobody is missed in the story. All right, okay. Now we have this, we have that. Now here's a small suggestion. I think we have passed the hour mark. I've given that C# part which I needed personally. So because when I will write in Unity code and the C# code in Unity, everything will just, all hell will break loose. I hope not for you guys. So we're gonna go into the introduction of computer graphics because I need to teach you what are the terminologies, how things are working. Because when Unity spits out errors at you, you have to understand what the heck Unity is telling you, so you know where are you shooting yourself in the foot, or which foot you are shooting at least. Okay? So I will give you a break of exactly, I would say, 10 minutes. Okay? And then we will move on. I think your classes should be done at 1, isn't it? So it's actually from 11 until 1, isn't it? Guys, are you still alive with me? Okay, good. All right, then I will actually just mute my mic. I will come exactly at 12. Oh, it's actually 12 and 10. How about 12 and 12 and 20? Is it good for you guys? So you can drink water, we'll do whatever you would like to do. Okay, 12 and 20 it is. See you then. Are we back to our seats? Is everybody still there? Okay. Još minut, eto. Actually, 15 seconds. Actually, even less. All right. All right. All right. Let's talk about the fun stuff, which I think some people might find a little bit, well, it's not complicated. It's its own beast, I would say. First of all, I hope that you will not mind my mouse art, but this is the only way I can actually draw this. I don't have a tablet near me that I can share with it the screen. So I will go actually with it. Now, when you ima li iko ovdje koji igra igre? Ne znam sad. Samo da bude jasno, naravno, dobro, cool. We have people who are into that stuff. Ima li iko koje igra, ja pričam oko, pa dobro, sve su isti, mobilne igre i računara, ali ja ću dati primjere iz. I think everybody have heard about Counter-Strike. I think at least the ladies have seen some screenshots of it, if there are gamer ladies out there. Because mostly the ladies, they don't. Mostly I've been with a lot of gamers before. A lot of them, I've seen a lot of lady gamers, but the majority of them, they usually avoid this part, or they just simply like hide themselves for some reason or another. So hopefully if most of the boys, I think they know already about it. The ladies, I hope that they heard about Counter-Strike. I will take it as an example for a 3D thing because this is the closest thing I can convey to you. I have been into the games and playing games like games which have been published in the 80s and the 90s, so even earlier ones, even way before that. But I will actually try to get to the newest ones, so we can have some sort of a common ground. So I will not go really way back. I'll just simply use Counter-Strike because it's a 3D and it's fun. So what happens in your computer when you actually run a graphical application? So whether it's a 3D Max or actually 3D Max is a little bit interesting, but more interesting. It has other things into it. But I would say 3D Max and Counter-Strike and other games, you in fact transfer. You have to write a certain amount of code that describes a geometry. Okay, now how this geometry is described was in fact debatable until people reached to a point where they say we're going to use triangles to describe our geometry for several reasons. In fact, the first reason is it's actually the simplest polygon you could ever make. The second reason is it is easy to determine where the actual thing is facing, where the actual polygon is facing. Because why you need to know this? Because you would like to do light calculations. So if the face of a triangle is pointing outwards towards your face, then I would say that this polygon is visible and is pointing towards my face. And if I do some light calculations, I will use the blue color right there. And if you do some light calculations, your light is in fact a vector which runs from the light source to your polygon, and then it just calculates cross products and other dot products on the vectors, and it just simply says, aha, that thing is facing outwards and it faces in that direction. So if it faces completely at your camera, at your face, I mean, if it faces towards you totally, it will be completely bright. And if it starts to face away from you, it will get darker and darker and darker until you get a nice shade of these, like a nice shade of light. So you have a very bright spot right here, and then, you know, less and less and less light towards the edges, let's say. This is called the per pixel lighting, by the way. Per vertex lighting is that the light is in fact hitting those endpoints. And if it hits those 3 points, it will completely illuminate the whole triangle. If it actually hits only 2 points, and it doesn't hit this little guy, most probably you're going to see a little bit of light here, intersects with a little bit of light there, and this part, this area at least, will stay completely dark. This is with the very old games. I think you should have seen it in play. If somebody's seen PlayStation 1 games, it is more or less somewhere around this, having these interesting problems. Now, we used long time ago when Unity first time appeared, like Unity 3 or Unity 2 and 3, I cannot remember really which one. We would actually, for mobile phones, because mobile phones back then, like in 2000 and what, 7 or 8, or I cannot remember anymore. Honestly, they were really, really weak, and this was like Android just came out and iPhone was just coming out, and the graphics chips weren't that very powerful like right now. So mostly you have this tick mark in Unity. You should say, hey, I would like per vertex lighting. Your lighting is shitty, but it's in fact working, and it works quite fast, that you get 30 frames per second, let's say. Okay. Right now, because our phones and our computers are way, way faster than our supercomputers compared to like computers from 20 or 30 years ago, right now people just simply they never use per vertex lighting anymore, I think, except for really edge cases, like if you were doing some interesting hardware, working on interesting legacy or very low powered hardware where you cannot do too much of graphics, I would say. Okay. So that's the first thing. So everything we can approximate in the universe with triangles, anything, absolutely everything. And if you don't have enough triangles, you just simply add more, and the thing will get smoother and smoother and smoother until it gets, you know, perfect that your naked eye cannot see. So that's why if you run something like Blender, honestly, they have changed it a lot. I cannot really remember too much about it right now, how to model in there. But I hope that I can create a sphere. I think I create a sphere here, add or E. Hang on. There was actually a button for that thing. Modeling. Oh, this is extrusion, layout, scripting, animation, rendering, compositing. Honestly, I forgot actually that they have changed a lot of things in Blender. Hang on. Let me give you up a sphere right now. So, sphere, 3D, and you can have a perfect sphere like this modeled in Blender with no problems at all, and your computer will just crunch it and it's 100,000 polygons. Yeah, there you go. So you can do this in a fraction of a second on your phone right now. Before, like 15 or 20 years ago, I've done the same scene, which you see right now, and it took on my computer like 10 minutes to finish it. So you can imagine how far we have actually got. So let me close this. I don't need actually Blender right now. Now let's talk about the other thing, about the triangles. Now the interesting part here about them is they are coplanar. That means that you can actually align those 3 points, however you put them. So if you put it that way, you see, I'm trying to tilt it as much as I can. You put them in this way, you will always have the triangle lying, all of the points are lying on the same plane, which makes the math for light calculations much easier and much faster. This is one thing. Now, the second thing, regarding the pipeline. Once you have your triangles done, so once you have your 3D model has been created into your memory, so that's why you need a lot of RAM. This is why games require RAM and CPU power for the very specific thing. Your code or your program which you write for creating a 3D object gets thrown into the RAM. Okay? Now, your RAM and your CPU and your GPU are all of them according to the, I think up until now, I think all of them are on the same bus, on the same system bus. It's called your PCI Express, your CPU and RAM are all connected to the same bus. And if you have a PC, not a laptop, please do not open your laptops. I'm not responsible if you are curious. You open your PC, you look into it, you will see that the very interesting thick lines coming out of your RAM, if you follow them carefully, you'll see them going through the CPU die, like somewhere around it, and then you will see that these thick lines still continue to your PCI Express, or at least the primary PCI Express, okay? So your program shifts into the RAM, gets calculated by the CPU, gets transferred later on to your GPU memory. Okay, so this is your graphic card. And right now, all your calculations are happening in here. So this is your calculations are happening right there. If you would like to move the scene, transform things, running around, moving your camera, the grass is waving, all these visual effects are happening, in fact, on your GPU. Okay? Now, the less movement around this is the better for your performance. This is why people try to shift everything up to the GPU as much as they can and minimize the amount of transfer between your RAM, CPU, and your GPU, because both of them are completely different worlds. Okay? Now, this is like in a very nutshell what is happening inside your computer when you actually run a game, or run a graphics application. It loads the stuff that loads the geometry into the RAM, shoots it to the GPU does the calculations and transformations, then it actually throws that image onto your machine. Now, how this is actually happening? This is the interesting part. Now, you have inside your GPU, you have several things. You have something which is, you have many buffers, okay? Areas of memory which programmers can write to. So you have frame buffer, you have depth buffer, you have, I don't know, there are many of them. You have stencil buffer. Anybody played Portal? Anybody knows about Portal, the game? Good. Portal relies on stencil buffer, dear sir. This is how they actually punch holes into the geometry of the area of where you are going. So when they shoot when they shoot against a wall, using the stencil buffer, they create a matrix where they say, okay, this part of the geometry will not be rendered. They modify the physics, so they actually take out the collider from this area, so you can pass through that thing. They project an image onto that area, because that image actually, you think it's an image, but you think it's an area, but it isn't. It's actually an image. They have another camera pointing to the place where you are looking at, flipping the image backwards, showing it to you, all of this at the same time, happening on the GPU, giving you this illusion that you are actually passing through the hole, while you actually, well, yeah, you're passing through the hole more or less, but yeah, I think you get the idea. So they really project a lot of things. They do a lot of voodoo magic with the GPU, so they can relying on the stencil buffer, depth buffer, and the frame buffer and other things, in order for them to, play with this idea that you can pass through walls and stuff. Okay. Now I will not talk about the physics engine part because the physics part is crazier and crazier how this is actually being implemented, and it's actually outside of the scope of this current talk, so I will not actually delve into there. Now you have many buffers into here, okay? What interests us though, I want to talk about the stencil buffer because it's actually an advanced concept and you will never touch it unless you are doing something really good and advanced. You're gonna actually see the frame buffer where all the pixels of your application is just being thrown in there. Once that frame buffer is completed, it will just simply project it onto your monitor. Okay. So how this is actually being done, which is a good question too. So the first thing, your polygons gets transformed. Yeah, I have to talk to you about matrices first. But let's say that your polygons are actually, let's say that this is a square. It gets divided into four or actually two triangles. So you have the A, B, C, and D. And you have something which is called the polygon winding. Winding means how you rotate things. If you Google winding clocks or winding watches, that is the watches which you just simply wind in order for them to fill in the energy so you get the kinetic energy for it to move. Okay, that's called winding. And winding in here means how the description of the polygons or the vertices are being made, or how do you describe them, their order, let's say. So if you put everything counterclockwise, which is I think is the practice so far, I think, then they say that the polygon is actually pointing towards you. And if the things has been described clockwise, then the polygon is facing away from you. Now, the point here is you need to know where the polygon is pointing, because if it's pointing outwards, means that the light is like when the polygon is being hit by the light, and the light and actually that polygon with its winding is facing towards you, then you're going to see that polygon. If it winds in the opposite direction, then you will not see it. You shouldn't see it because it's pointing away from you. This is, by the way, called back face culling. If you are not familiar with the concept, so back face culling. This is one optimization point where you just simply eliminate polygons so you will not see them if they are unnecessary. Why I'm telling you this? Because once you have the order of polygons set, you cannot change them. All the world has to behave in that way. In Unity, you can set that up. I advise you don't touch it or you don't modify it. You just use it by default as is. If you see some polygons disappearing from you, let's say you get inside a cube, so you are zooming in, zooming in, zoom in. You zoom in inside the cube and the cube is gone. You don't see anything. You just simply see the whole thing through it. You see through it because of the polygon winding. We're going to see that later on in other lessons. So these guys gets described, gets actually aligned in your So they actually get described or get allocated into your coordinate system. Fine. And once they are described into your coordinate system, so let's say you have this nice square. We use matrices in order for us to project the stuff in front of your monitor. Now, why we are using matrices in the first place, and why we are using in 3D graphics 4 dimensions instead of 3 dimensions, which is actually a very good question too. Let's say you have, let me undo this, or let me just have this, and let's say you have a triangle over here or there. Okay, so let's say you have a triangle. This is 1, 0. No, sorry, this is actually 0 for x and 1 for y. And this is minus x and this is plus x, right? Okay, so these are our simple coordinates. Now, if you would like to move this triangle, movement is an additive operation. So you say, I would like to add one more to that thing to that point into X. So I would like to move this point right here. So you add to it. So I'll grab this. So you add to it in order for it to be here. So it's going to be at the end 1, 1, right? And if you'd like to add this point, you add to it in order to move it. So actually, sorry, if you would like to move that point, you add to it in order to move it. And it's going to be, if you add it by 1, 1 minus 1 is going to be 0, so it's going to be here. And by the way, we do it in a vector form. So if you say, I'm going to move in X and 0 in Y, and I'm going to add minus 1 in X and 0 in Y, you're going to actually move on, and you're going to find yourself here 0 and 0, which means that the point is here. And then you move this little guy, which is going to be 1 by 1, so you would like to move it by 1, and then you're going to have here 1, 0. So its new, oh boy, its new coordinate is 2, 0, which is going to happen to be somewhere, let's say, here. Okay, so you got your new triangle right there. This is how translation works, by the way, in graphics. You move everything vertex by vertex. So if you have a guy running in Counter-Strike, and the person is like what, 50,000? No, 10,000, I think, or maybe less, 10,000. No, actually, it should be less. Oh, yeah, it doesn't matter. So let's say they have like 10,000 polygons at least, 15,000 polygons at least. So 15,000 polygons. And I say 15,000 means that you have a triangle. When I say 15,000 polygons, it's 15,000 triangles at least, times 3, which is these, I don't know how it's going to be. So I think what 6, 30, 45, I think. So there you go. And you say like around 45,000 points. You have to move them every frame. This is for one character. Right? If you have a team of people, then the things just goes bananas. Right now you have like what? Let's say if you have 4 people, like right now you are playing with 180,000 points, which you have to translate every time per frame. So every frame you add these 150,000 points from one position to the other. Now, if you look at scaling, for example, scaling is a multiplicative operation. So if you would like to scale this up, you just simply multiply. You say, I would like this 2 times bigger or 2 times less bigger, right? So let's say we'd like to scale this by 2. So you say, for example, I will actually scale this by 2 in X and Y. That means you have a uniform scale, so you uniformly scale in all directions. And you multiply by that vertex, for example, you will get a certain number. So you get, let's say, 2, 0. So at the end, the position of this vertex, because I'm scaling right now, I'm going to have it right. Oh, boy, hang on. I thought that I'd chosen another color. So there you go. It's going to be here. And it's going to be 0 for Y, or X. Hang on. I made a mistake, actually. No, I haven't. No, I did. X and Y. Oh, okay, I made a mistake. So this actually has to be 2, and this has to be 0. Okay. Good. Now, and this is going to be 2, and this is going to be 0. I mean, you get the point. So if you start scaling these stuff up, you will get, for example, a triangle that's yay big. Right? Rotation is the same thing. Rotation is a multiplicative operation. You need to multiply by a certain angle. So you have cosine and sines, and you have to multiply by a certain angle in order for you to rotate the actual polygon. Now you run into a certain issue here. If you think about performance, you would like to move, let's say, 150,000 points, rotate them, and scale them. So let's say you will not scale. Let's talk about movement and rotation, because characters in Counter-Strike, they don't scale, I think. Unless you put a hack in there, then it's another story. So they run, so people run, they jump, so you run and jump, and then you rotate around yourself, right? So you can look, scan around. So you need to add the position 150,000 times, and then you multiply 150,000 times, which is like 300,000 operations per frame. And you do that 60 times per second, which is an overkill. So you don't do that. This is why people are using matrices. And this is why graphic cards, they are super good with matrices because people have seen the requirement. People who've actually made graphic cards, they have seen the requirements of games, and they said the best thing we can do is make processors that they can crunch matrices very well. This is why we actually use matrices because not only that, but because with matrices you can actually combine all operations into one. So let's say you would like to rotate, so you'd like to translate. So let's say I will take the identity matrix. You would like to x, y, 0, 0, 0, 0. This is actually for translation. And then you would like to scale. So you scale with the same matrix, 1, 1, 1. You have the 0, 0, 0, 0, 0. As far as I remember, this is your scaling matrix. Okay? You modify these numbers, you scale. Okay? And this is for 2D scaling. Now I'm using 3 dimensions in 2D for a good reason. Because the problem with matrices in general, or the problem with rotations and translation and scaling, translation is an additive operation. Scaling and rotation is a multiplicative operation. If I would like to combine them all into one, I have to multiply all of these matrices into one. Now, one of the interesting properties about matrices, if you multiply them by one by the other, you actually combine all their operation into one single thing. And for example, if you look at the translation matrix by the rules, it's actually looking like this. And if you can see carefully, you have already the identity matrix, and you have the scaling matrix, let's say, and you have the x and y translations as well. Now, if you modify this number to 2, you're going to scale and you're going to translate. If you can put here, for example, 4 and 5. Right now you scaled and translated at the same time with one matrix. So if you have 150,000 points, you multiply them by that matrix, you're going to have scale and translation all happening in one operation. So right now you have all this combined. Now, if I didn't write the rotation matrix, but if you multiply the rotation matrix by that matrix, you're going to have rotation, scaling, and translation all into one. This is also one of the reasons why people are using GPUs in AI, because AI does a lot of matrices, and GPUs are super fast in crunching these numbers. So that's why you have, or if you do matrices on your CPU, then it goes crazy. But if you do matrices on your machine, or your graphic card, things go super fast. Now, it's important to note that one of the differences between GPUs and CPUs in terms of the architecture, CPUs are MIMD, so multiple instructions, multiple data. GPUs are single instructions, multiple data. So you have a single instruction, your job and only job is, for example, at a certain point in time in your code, translate, rotate, and scale for all of these vertices. So multiple data, please grab that vertex, do that same operation. Please grab the second vertex and do the same operations, and so on and so forth. Okay, so this is how your GPU is going really super fast in moving objects into your scene. Okay, this is how the transformations is happening. It's important to note here that your professor will actually discuss the maths and the details behind how the matrix is actually being multiplied, how the things work. So I will not actually take over this part. He will actually describe it in nice details. I need you just to be aware of it, because I'm actually going to start coding next time, and you're going to catch up with him again later on in his lectures. So you're going to be all on the same common ground. I just needed you to know these simple facts so we can move on. Now, there's one more important thing. I was talking about buffers and stuff. So let's get into details about this before we finish up. You write your code. You transform your game. Your game goes into several transformations. The first transformation is it goes into its world space, right? So we have into world space. Now world space and local space, we're going to discuss them later on when we get into Unity. So you can see this visually, but let's take this for granted for now. So you have the world space and you have the local space. Sorry, hang on. It transforms first, it gets described first into the local space, and then from the local space goes into the world space. Hang on. Oh boy, not you, not you, not you, you. So it goes from here to the local space, the thing gets described into the local space, and then it gets put into your world so you can see it. Because if you don't see it in front of you, then it's, I mean, if it's not in the world, you will never see it. Then this actually gets transformed into your camera space. This is how you see the stuff into your scene. If you don't have camera, you don't see stuff. You don't see shit. You just simply see black screen. So this gets projected into your camera. Now all this is in 4D, more or less. Now you have a lot of other transformation that gets the stuff into 3D, besides something which is called scene culling. So anything, you have a world perimeter. So anything outside of the world will disappear. You will never see it. So this is called the camera culling part. So if you have a camera, usually they are like this. They are a prism most of the time. You have it depends. This is called a perspective projection. So things where they are farther away, they are smaller. When they are closer, they get bigger. You're gonna see this. You have orthographic, which is similar to the old strategy games. I don't know if somebody have played Age of Empires. I know that I'm testing your ages and memory. I think most of you are too young, I think, for Age of Empires. Anybody played Age of Empires? Okay, we have one. Okay, good. This is actually called orthographic camera. Okay, if you play the Age of Empires, if you play these things, these are, or this is actually orthographic camera. Basically, everything is in parallel. Nothing gets smaller or bigger when it gets farther away from the camera, more or less. So yeah, it gets projected later on into your camera space, and then things get to transformed, multiplied by certain matrices, which I will not discuss here because they are outside of the scope right now, and gets flattened out into a 2D image, which later on thrown onto your frame buffer. Okay, so your frame buffer contains it. Now, you have something which is called depth testing, because you need to know which objects behind which. And you keep that stuff into the depth buffer, which I've talked to you about a couple seconds ago. So you have the depth buffer. And the depth buffer says, this object is behind that object. Please hide that pixel and do not show it. So once your frame buffer gets rasterized or shown onto the screen, things get shown appropriately how things are behind which. And believe it or not, it was actually a quite big problem in the graphics world for a really long while. Like in the 60s and the 70s, they had really problems. And then they made a huge drum, which they made the depth buffer. I cannot remember the size of it. It wasn't even a K, I think, or maybe it's 1K or something like that, where people actually successfully could be able to do this operation to determine what is behind what, and so on and so forth. Right now, of course, it was super expensive to make and super expensive operation to do the depth thingy. But right now, with the new technologies and how computers have actually advanced and so on and so forth, with, for example, the first Doom and when first Doom appeared and the one before it, and Quake and other ones, well, they started to utilize 3D graphics and they started to do these interesting drawings. Before, by the way, when we didn't have a depth buffer, we used something which is called the painter's algorithm, where we draw the farthest thing first and then we move on, which solved the problem of transparency. So if you have a window, you can see through it, and if you don't have the depth information, or if you didn't draw things in order, you run into a problem where things go through other things, or just simply things disappear altogether. You just don't see stuff. So yeah, this is basically it. So depth buffer is depth buffer is important to understand. What is it about? You need to understand about the frame buffer. The frame buffer, by the way, all the special effects like bloom, motion blur, all these all these other interesting things are happening on the frame buffer. You have, when it comes to depth, depth is another story, but I think more or less this is it. If you see, I mean, once we run into other errors in Unity, you will see other keywords which I'm going to describe on the way, but these are like the bare minimum stuff which I wanted to share with you so you know how things are functioning and what it's all about. So once you see errors regarding the frame buffer or things that you are outside of the bounding boxes, so for example, if you're outside of the bounding box, which is this little guy, when things disappear, it says, hey, you put the object way far in the scene that went outside of the perimeter of the world space itself, you're going to get these errors. All right. So right now you know these keywords. So once you see them in Unity, you understand, I understand what it's about. Okay. Probably it's a little bit too much to take in all at once, but we're going to actually revise them again once we run into them again in Unity. Okay. Any questions? I mean, anything is not clear for you guys? Oh wow, was it too overwhelming that you guys just completely went out of text and you cannot type anymore? Hello? Kinda. Oh well. Yeah, it usually, I mean, yeah, it's maybe it's a little bit, but anyway, this is like, actually this is the simple stuff. Well, okay, it's yeah, it's I had to crash it somehow because there's no I mean, I would have actually taught you OpenGL. It would be more fun, and you will get touching this stuff by your hands. But we're gonna revise them again anyway. Može pitanje na email kada ovo se testiramo. Oh yeah, sure. Just send me emails and stuff. Right now I have to run into my classes. So if you guys do you guys have any other questions? And if you kind of shy to ask in the live chat, please shoot me an email. I'll reply them ASAP. But I'm gonna be a little bit late with the reply since I have a class right now. Hang on. Senad Rahimic. Any other questions? No problems? No more questions? Okay. Then feel free to shoot me an email and I will actually reply it as soon as I get to it, okay? Hopefully we'll see you in the next time. Take care. Bye. Feature.